Good morning, students. This is Suraj Patel and welcome to Maths Chef YouTube channel, right? So, we have done 6 chapters, the triangles and solve the Pythagoras theorem also, derive the equation. And now, chapter number 7 is next, moving forward, coordinated geometry. Coordinated. The name suggests, okay, in 9th class you already studied the basics of the coordinates. What are the coordinates? The system of two perpendicular real numbers, okay? What the coordinates is system of two perpendicular coordinates, right? What the coordinates is coordinate means, okay, system of two perpendicular real line, right? This is the R1, this is the R2. So this is called where the R1 R2 the real number exists, meets na intersect na, that is called axis, is called origin. Okay, this is the O called origin, right? The vertical line is called y axis or y coordinate. This one is called y axis or called y coordinate, and then horizontal line is called x axis or called x coordinates. X coordinate also, okay? X coordinate also x axis, okay? The distance here from the point, distance on the x is called abscissa, okay? Is called point A. So OA is called abscissa, right? The height is called here, this is called ordinate, this is B. OB is called ordinate, okay? Similarly here you can write, okay, this is the point here, distance, this is the point, okay, let's consider 3 and 4, okay, this is called ordinate, and this is called abscissa, okay? Before going to this one, so these are all imaginary figures, right? In real life they are not exist, but they have the real life application, okay? On earth, on school, on building, this does not exist, but this is the reference line, imaginary line, okay? So here we can make our calculation easy. We can find the way, the cross, the building construction, the physics, the formulas. We can make, you can understand the shape of the equation here. So let's consider you are staying in a village, something else. There is the home here, okay, home like that, okay, home is like that, okay, yeah, home, and you have the temple here, okay, temple here, and you have school here, okay, school building, something else. Then I have the road here, and you have this cross road, right? And you have this some park, okay, park here, something else here, okay. Some points are here also, some points are here, okay. Some homes are here, so, okay. Hospital, what we call hospital is here, and government building is here, okay. Government building is here, something else, okay. Then all symbols, okay. Parking area is there, okay. Something, okay, whatever it may be. So see, this is the random area, okay. This is the random area in your city or in your village, okay. See, here we don't know distances from hospital, from school building, from temple, from home, from another one, home 1, home 2, home 3. This is the park. This is the okay, park. This is the parking area. This is the park, okay. Then this is the parking place, building. This is the hospital, right? So here we don't know. So from home, temple to government office, I have to measure. From home 2 to home 3, I have to measure, right? So what I'm doing here, exactly. So I am dividing it exactly 4 parts. So this is called y-axis, this is called x-axis, and this is called center point. This is the 0, 0, right? This is the reference line. Okay, reference line. So to go to temple, first go to the east and take north, right? For the government office, again go to the some minutes of east and go to the north side. If you want to go to the this one, which one? Hospital, go to the east and go to the south for some minutes, or come to the south for some minute and go to the east for some minute. Right? So for something for the temple to see. Right? From home on to parking space. How will you go? Okay. Again you come to the find this one axis reference line, this unit, and you will go to this one and you will come to this side and this area. South east direction. Okay, so here I have to round by because this is the reference point. You get the exact line. No? See, if you want to come direct here, what you will do? A straight line. No? A straight line. How to find distance here? Okay, this is only for ideal. Okay, for reference only. Just think about there are thousands of houses. Okay, the big city. Okay, if you take the distance here, then by mathematical calculation we can find the figure of the. See here, you make the distance now perpendicular. If this is 8 kilometer, this is 9 kilometer, then obviously we can find it. This one 8 square plus 9 square root of this one. From this point, again this point is for 10 kilometer. This is 2 kilometer. Again this kilometer will be 10 square plus 2 square. So add this one you get the distance from here to here. This is the imagination, but this is the real work. Okay, this is the imagination, this is the real application. In any city and village, you can take the point. So just you can measure the boundaries. What are this distance and what are this distance, what are the current distance, what are this distance. And then you can find out the points somewhere else. Right? Okay, by taking the point from this and this, you can find the distance. Right? This is the application, but still in 9th class we studied the vertical line is called y-axis, the horizontal line is called x-axis, the distance on the x is called abscissa, and distance on the y-axis is called ordinate. Right? This is the point. Okay, this is the point, general point called P of x y. You should take the P of x y only. Right? Let's take this sum. They given distance found directly. Okay, and here also for the first quadrant. Okay, the quadrants are the parts made by the perpendicular real number system. Two perpendicular real number parts. What the quadrants are? The 4 different parts are made by the perpendicular real number system. This is called quadrants. First quadrant, second quadrant, third quadrant, fourth quadrant. Again, so from origin, the upper side of the x is called positive side. This is called positive side, means you are writing 1, 2, 3, 4, 5 up to infinite. And the lower side of the origin of the ordinate line, okay, is called negative line. Negative. This is called -1, -2, -3, -4, -5, -6. Right? And right side of the origin x-axis is called positive again. Positive x-axis is called 1, 2, 3, 4, 5, infinite. Again, the left side of the axis is called negative direction. -1, -2, -3, -4, -5, -6. Why? Because these are the perpendicular real number lines. Real lines. Because the real lines you have all values. Negative integers, positive integers, 0, rational numbers, whole numbers, natural numbers, even also irrational numbers you can have. Okay, only for irrational numbers now you can make this diagram properly. Otherwise quite difficult. Okay. These are the real number 1, real number 2. The right side of the x is called positive and left side of the x is called negative direction, and negative points are integers and negative values, and the upper side of the origin of the ordinate is called positive values and lower side is called negative values. These are the basic introduction. Okay. Then the first quadrant is, okay, here, see here, x also positive, y also positive. Any point on the first quadrant is positive and positive. First quadrant is both points, both coordinates are positive. In second quadrant, what we have? Second quadrant we have x is minus x and y is positive. In second quadrant, x is in minus direction, negative values, and y is the positive values in second quadrant. So in third quadrant, what we have? Both x and y are negatives. See, you can take minus 5, minus 3, minus 6. In all these quadrants, you get only negative values only. Similarly, fourth quadrant, what we have? X is positive and y is negative. It's called fourth quadrant. Okay, quadrant. Quadrant, quadrant, right? Okay, our whole the navigation system, the aeroplane movement and the ship movement, that navigation system, nautical miles, I can call a ship movement, ship navigation also depends on this, and there are also which one? Longitudinal latitudes. Okay, longitudinal latitudes also depends on these imaginary lines. That is the real application. That is the Earth system, right? This is the called latitude 0. Okay, latitude 0 latitude, and this is called longitude. Okay, this is 0 called longitude. Okay, see, these are like that, right? These are called longitudes, right? These are called also the imaginary lines on the earth, right? Imaginary lines on the earth, right? All lines are okay. Okay. This is not correct. For longitudes, see, longitudes have different size, okay, distance, okay. This is the like that longitudes. This is the system. Longitudes are okay. This is the system. But at 0 equator becomes distance 0. Okay. They are not coinciding, unlike longitudes. Okay, latitudes have the constant distance. Unlike longitudes, they have intersecting at the point North Pole and South Pole. But latitudes are not intersecting at the East Pole and West Pole. They have the constant distance. Okay, they are okay consecutive circles. Okay, consecutive circles. The distance, the whole circumference decreases with respect to height. Okay, that altitude means longitude. You go to the north or south. Okay, there the 0 is the 0 equator. 0 latitude called equator is the largest distance, largest perimeter. Okay, next. And coordinate geometry, have introduction about y-axis, x-axis, what is the abscissa size, distance on the x-axis, and what the ordinate is, distance on the y-axis, right? Okay, let's check some examples. Okay, the points on x-axis and points on y-axis. Okay, any point on the x-axis and any point on the y-axis, how will 0, 1, 2, 3, 4, 5, 6, 7, infinite, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, infinite, -1, -2, -3, -4, -5, minus 6 infinite, and positive 1, positive 2, positive 3, positive 4, positive 6, positive 7, positive 8, infinite. Already we know this is the 0 and have O is point is 0 0, means the 0 distance from the axis also and 0 from the axis also. Okay, see any point on here, I am taking the 4 and there is no value of 0 here, right? I'll consider this is the point 0, consider take is the 4:1, this is the point 4:2, 2, this is the point 4:3, this is the point 4 to the minus 1, this is the point 4 to the 4 and minus 2. See, at the point on the x-axis, okay, at x-axis, very important, value of y is 0. At x-axis, value of y is 0. Similarly, okay, similarly take the y-axis, what you can write as 0 and 6 because the 0 line, and here can write 1 and 6, 2 and 6, 3 and 6, again also minus 1 and 6, minus 2 and 6, minus 3 and 6. Okay, this is the line. Okay, these are the points. These are the points here. Okay, so here on y-axis, x is 0 always. Very important. Whatever it may be. In this also, x is 0 and y is minus 4. And here also, y is 0, x is minus 4. Okay, generally we can call it minus 0. This point, okay, this point generally we can call it minus x and 0. Generally we can call it 0 and y. Generally we can call it 0 and minus y. Generally we can call it 0 and okay, x and 0. Okay, any point on x-axis, the y coordinate is 0. Any point on y-axis, x coordinate is 0. Any point on, see, whole line, x is 0. So this whole line, y is 0 on this line. Okay, this should be very careful solving the examples. Okay, right, then go to the distance formula. Introduction we have already. Let's see the distance formula. Distance formula means distance between 2 points. Okay, the word stands. Distance formula means distance between 2 points. So 7.2. 1.2 distance formula. Okay, distance formula, right? So okay, and again I'm telling the okay, this is the first take the okay, let's take another one, new one. Okay, this is y, this is y, this is y dash, this is x, this is x dash, right? So if I have to find distance between this one, okay, 0.5, okay, this is the 1, this is the 2, this is the 3, this is the 4, and this is the minus 1, minus 2, minus 3, minus 4, minus 5. If I want to find the distance between this one, you can write as 1. If I want to find distance between this one, as can write root 1, 2. This is 3, okay. This is 1, and okay, not right here, okay. The whole distance becomes this one is 2, and this one becomes 3, okay. And if you want distance between 2 and 3, right? If you want to make distance between 2 and 3, this is 1 unit. So can I write 3 minus 2? Okay. This is point 2 and 0. This is the point 3 and 0. Can I make simplification here? Okay. Distance, this I can write as 3 minus 2 into, okay, the point is, and 0 minus 0, again we're getting 1 and 0. Okay, the distance is, point also like that and distance also like that. In axis you can find the distance very easy because they given. Okay. Right. Here also distance we can 1, 2, 3, 4. Okay. We can find distance here, but if I want to find distance between, right, 2 and 3, point 2 and 3. Okay. If I want to find distance between 2 and 3, what I have to do? Okay. Again, our triangle system is helps here. Okay. That's this chapter given after the completion of the triangles. That's the similarity triangles. Okay. And Pythagoras theorem also, because it has the basics in inherent features of triangles and Pythagoras theorem. Okay. This is the distance now. See, here I can draw line from this. So this becomes A. And here also I can draw line with the B. Right. This is the point P. Right. So from O to A I have two units. From this one 0. This one point 0 is called from so to y axis. This one to this have 3 units. Okay. This have 2 units and this have 3 units. Right. So this is the 90 degree I am making. Right. Now we found the right angle triangle. Right. This is the right angle triangle construction. So this is 3 is the equal. It becomes square also you can tell. You can have parallels also you can tell. Okay. So this becomes equal to the O and OB is equal to AP. By figure you can conclude. See, this forms a right angle triangle. Where the Pythagoras theorem is base square plus height square is equal to hypotenuse square. Okay. Then OP becomes, okay, OP becomes square root of 2 square plus 3 square root of 4 plus 9 square root of 12, 13. So this is square root of 13 units. Okay. We taken this distance na 30 units. Okay. Okay. 30 units is the distance. Okay. Let's write here. Then how should we write this one? I am writing this one as C. OP is the OP square is equal to what the distance is? OA square plus AP square formula. Okay. What is OA square is? OA is 2 units na? Okay. What I am writing is 2 units. I am writing is 2 minus, okay. This is the OO. OO. I am writing as 2 minus 0. X distance. 2 minus 0 whole square plus what is AP here? AP is here again. Okay. AP square is, can write 3 minus 0. Distance is AP na 3 minus 0. 3 minus 0 whole square. This becomes again 4 plus 9. This becomes 13. Therefore, OP is equal to square root of 13. Okay. This is the method we are going to use. This one. Okay. Let's find in normal areas. Okay. Distance of the 2 other points. Let us again, this is the axis y, this is the x-axis y, y dash, x and x dash. This is the point O, 0 and 0. Okay. Let's take the point different here. X1. Okay. The point here x1 and y1 P, and the points here Q, x2 and y2. Okay. Sorry. So I want to find distance between these 2 points. See what I am using here? Distances are taken 2 minus 0 and 3 minus, okay. 2 minus 0 means 2 minus 0 whole square plus 3 minus 0 whole square. 2 minus 0 whole square plus 3 minus 0 whole square. Right angle triangle method. So here, what do I do? This is the distance, okay. This is the called x1. This is the distance. This is the called. This is the all is x1. So this is all is x2, right? Again, this is the distance y1. This is the y1. The whole is y1, and this is the distance y2. The whole is, right, y2. Okay. So this is the base. Okay. This is the PQ. Okay. A, B, C. Points are like that. A, B, C. Okay. Very important. What I want? Distance between the P and Q. Okay. This is the right angle triangle. PQC, the right angle triangle. Right. I am going to write the equation by this problem. This is only figure only. Okay. Just look at here. Right. This is the whole distance, and this distance becomes x2 minus x1, x2 minus x1. Similarly, this is x2 minus x1, and this distance becomes now y2 minus y1, y2 minus y1. This whole distance becomes, right? Can I write this one as, not in brackets, write this one as, okay? So here, write PQ. Okay, right. PQ square or PQ is equal to square root of, by Pythagoras theorem, what we have? PC square plus QC square. Right? What PC square is? Right? Directly I am writing. What PC square is? AC, no? AC square plus what is QC is? Oh, this point is right, D and E. Right? D and E square, okay? D and E square. What is AC here? AC is x2 minus x1 whole square. What is QC is? D is y2 minus y1 whole square. This point is y2 minus y1. This point, only the E. Okay. y2 minus y1 whole square. Okay. Therefore, what is the PQ? Can I write? Writing PQ as D. Okay. Very simple application, right? Only just the Pythagoras theorem you can use. D is distance between the point x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula for the distance between these two lines. Again, there is 2 minus 3 0 whole square plus 3 minus 0 square. Now, similarly, I am using x2 minus x1 whole square plus y2 minus y1 whole square. Only simple, okay? This we can write also x2 minus x1 square plus y2 minus whole square. You can write by this also, and you can write by this also, x2 minus x1 whole square plus y2 minus by y1 whole square under root of d is equal to. This is the formula. In special cases, okay? Special cases, okay? Distance from the origin, okay? Distance from the origin. Distance from the point or from the origin to the point. From the origin to have 0 0 to the point x y is, okay, xy is, what the formula here? x2 is x and x1 is 0. Okay, x2 is x and x1 is 0. X square plus, and y2 is y, and which one? y1 is 0. Y square. Like it, na? If you want to find the point from this one, this is the point. Okay, this is the point P of x, y. Okay, here I have taken x2 minus x1 whole square under root of y2 minus y1 whole square. Just simply take here x minus 0 whole square plus y minus 0 whole square. Right? X minus 0 whole square plus y minus 0 whole square under root of. That is the formula here. Okay. This is the equation. Let's find the formula, right? Okay. A given figure also, this is also possible. Okay. Find the distance. Okay, let's see the first point. Do the points. Let's solve the first question. Do the points let's solve the third question. First one is do the points 3 and 2, 3 and 2, minus 2 and minus 3, and 2, 3, 2, 3, form a triangle, question mark, form a triangle, and name the triangle formed, and name the type of triangle formed. Right? And name the triangle which are formed. Right? See, by distance formula you can see also, and by diagram also we can see. Because big question they have got complex. Let's see. This is the axis. Okay, this is the axis y and y dash, x and x dash. First point is, see, I'm taking randomly. First point is, okay, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, plus, sorry, minus 1, minus 2, minus 3, minus 4, minus 5, minus 1, minus 2, minus 3, minus 4, minus 5. First point is 3 and 2. This is first point, 3 and 2. Second part is minus 2 and minus 3. Minus 2 and minus 3. Here, no? Minus 2 and minus 2 and minus 3. This is the point, no? Minus 2 and minus 3. Third point is 2 and 3. 2 and 3 here. 2 and 3. See, let's join, okay, these 3 points. Okay, let's join 3 points. See, somewhere else. Okay, this is the point. Just find distance this one. Okay, this is the diagram for respect to this points, and we draw the line segments also. Okay, just find the distance between these points. Okay, let's find distance between 2, 3 and 3, 2. What is the formula? P is equal to square root of x2 minus x1, this is x1 y1 x2 y2 plus whole square y2 minus y1 whole square, right? This becomes square root of what the x2 3 minus 2 whole square plus 2 minus 3 whole square. This is square root of 1 plus 1. This is square root of 2. d1 is 2, right? Net addition with these two, okay? 2 and 3, okay? 3, 2 and minus 2 minus 3, okay? This is equal to d is equal to d2 square root of, okay, minus 2 minus 3 x2 minus x1 minus 2 minus 3 whole square plus minus 3 minus 2 whole square. This is square root of 5 square plus 5 square. This is 5 into root 2, right? 5 into root 2, 5 square plus 5 square, 2 5 square, 5 square taking outside, 5 becomes 5 root 2. This is root 2, this is, okay, 5 into root 2. Next one is 2 3 and minus 2 3, okay? 2 3 and minus 2 and minus 3, okay? Distance d is equal to, right, minus 2 whole square plus minus 3 whole square. This becomes square root of 4 square minus 4 square plus minus 9 square. This is square root of 16 plus 81, right? 16 plus 81, no? So this becomes 91 plus 6 square root of 97. This is 6, right? This is 36. 36 plus 6, 46. 46 plus 6 is 52. 52 you can do it, na? 16 is 6, not plenty. Okay, let's see the okay, let's see, okay, 52 square is equal to, okay, something else you can write. This is a big value, na? 52 square can write as 2 square plus 5 root 2 whole square. Pythagoras theorem using. Let's checking randomly because they asked us a type of the question. Triangle. This is equal to 4 plus 25 into 2. 36 plus 16 is 46. 46 plus, okay, this is 2, right? Yes, this is 52, right? This is root 52. Therefore, the sum of the two sides is equal to the other side. The square of the sum of the two sides is equal to the other side. Therefore, this is the right angle triangle. Therefore, these points forms a right triangle. Right? This is the shape. So you can call the sum of the two sides is, okay, sum of the two sides. So they given book like that. Sum of the two side is, okay, greater than the other side. Greater than the other side. This equals to right, or the square of the sum of the squares of the two sides is equal to the square of the other side. You can tell also. Sum of the square of the two sides is equal to the square of the other side. Hence, it's the right angle triangle. Okay, you can tell. That is the only thing that you can tell. As first condition is the form triangle face sum of the two sides is greater than the other side. Therefore, it is also triangle. Type of triangle means sum of the square of the two sides is equal to the square of the other side. Hence, it is a right angle triangle. Right triangle. Right? First question. Next one is show the points or what is of the square. Okay. The beginning only they give a complex questions. Let's see. Because the class 10 na, it's not a kids class. They have the authority. Points are 1742 minus 1 minus 44. Okay. Right. Show that the points 1, 7, 4, 2, 4, 2 and minus 1, minus 1 and minus 4, minus 4. Okay. Form the square or the what is of square. Show that. Okay. See here I am making diagram only. So in exam don't need to write this. Don't try to draw the diagram. Okay. Write the feature of the square. Simply the diagonals are simply the two sides. So it should be same, right? What I am doing here, just I am checking the. Okay, I am showing the how quadratus is working here. 0, largest is 7. 1, 2, 3, 4, 5, 6, 7 and 1, 2, 3, 4, 5, 6 minus 1, minus 2, minus 3, minus 4, minus 5 minus 1, 0 minus 2, minus 3, minus 4. But the first part is 1 and 7. 7, this is 1 and 7. Second part is 4 and 2. X is 4, Y is 2. This is the 4 and 2. Third one is minus 1 and 1. Minus 1 and 1. This is the right. Minus 1 and minus 1. Third is minus 4 and 4. Minus 4 and 4. Right. Minus 4 and plus 4. This is minus 4 and plus 4. This is minus 4 and plus 4. Okay. Let's join all these lines, all these points. Okay. Yes. Getting na? Nearly I'm getting, not exactly, but nearly approximate. Okay. The nearest shape is square. Okay. Then how to determine this? Okay. This one is, see, in squares, diagonals are equal. You can check these also. Or all sides are also equal. Okay. Then check the diagonals. Diagonal means na, just check the alternate points. Distribute the alternate. 1 and 7, minus 1, minus 1, 4 and 2, minus 4 and 5. They given the consecutive points, means adjacent point these are. If you want to check the diagonals without diagram, just check the which one alternate points. The distance between the alternate point, next points. Right? My 1 and 7, minus 1, minus 1. And 4, 2, minus 4, 4. Okay. First check the diagonals. Then you can check the sides also. Okay. Or you can check the sides also. First one is D is equal to, okay, 4 minus 7 whole square, square root, plus 2 minus 7 whole square is equal to, yes, 4 minus the 3 and 9, 7 minus 2, 5, 25 is equal to 34. Next, for the points again, consecutive points I am taking is equal to minus 1 minus 4 whole square plus minus 1 minus 2 whole square. This becomes square root of 4 minus 1 5 square plus 3 minus 2 minus 3 minus 2 minus 1 3 square. This is equal to 24 plus 9 34. For the points, okay, 3 points is over, na? Minus 1 minus 4, right? And no, minus 4 plus 1 square whole square plus 4 plus 1 whole square is equal to 3 square plus 5 square is equal to square root of 34. Last point is, okay, 4 minus 4 and 1 7, okay, minus 4 minus 1 whole square plus 4 minus 7 whole square is equal to 5, okay, minus 5 whole square. This should be I should write, this should be I should write, this should be I should write, right? Next, minus plus minus 3 whole square. This becomes again 25 plus 9 is equal to 34. Sides are root 34. Sides are root 34. Root 34. Or diagonals, alternate points. Okay. Diagonals is okay. D is equal to, one is completed. Square root of minus 1 minus 1 whole square plus minus 1 minus 7 whole square is equal to, this one is minus 1 minus 2 whole square is 4 plus minus 1 minus 7 8 square is 64 is equal to square root of 68. Also D is equal to square root of alternate points 4 minus 4 minus 4 minus 4 minus 4 whole square plus 4 minus 2 whole square, right? 4 minus 2 whole square is equal to square root of minus 4 minus 4 minus 8 whole square is 64. 4 minus 2 2 whole square is 4 is equal to square root of 68. Therefore this point forms, okay, this point forms square. Okay, this point forms square. Okay, let's solve the exam questions from the exam book, exercise points. You cannot directly know the formula, you can write to get the exact structure. Just check the points. Okay, you're getting confused over solution method. See, question number is, find the point on x-axis which is equation from the point 2 minus 5 and minus 2 and 9. See, question number is 7. Points are 2 minus 5 and minus 2 and 9. Okay, just I am taking the graph here, random graph. Okay, this is the origin. One point is 2 and minus 1. Okay, this is the point. Okay, this is the minus 5 2. This is the 2 and minus 5. Another point is minus 2 and 9. Another point is minus 2. This is and plus 9. This is the 9. Okay, this is the point is minus 2 and plus 9. Okay, find the point on the x-axis which is equation from the point 2 and minus 5. Okay, point on the x-axis. Okay, this is the point. Okay, this point we don't know, x and y. What the condition they given? Point on the x-axis which is equidistant from the points minus 2 and 9 and minus 2 and minus 5, right? 2 and minus 5 and minus 2 and 9. Okay. See, this line cuts exactly at this point. This point we don't know. The other condition is distance between this one and this one is same. Right? Let's write the solution here. Okay. Okay. So this is I called D1, I will call, and this is called D2, right? What the condition is here? D1 is equal to D2, equidistance, right? What is D1 here? X plus 2 whole square, can I write D1 square? It's okay. For simplification, I am writing the D1 square, D2 square. For simplification purpose only. X plus 2 plus y minus 9 whole square is equal to, right? Again, from this point you can take x minus 2 whole square plus y plus 5 whole square. Okay, I have to expand it, I have to make the solution. Okay, x plus 2 whole square plus y minus 9 whole square. Okay, let's do this is right, x plus 2 whole square minus x minus 2 whole square, right? This one is again y plus 5 whole square minus y minus 9 whole square, a square minus b square. In this formula I am explaining it. So a plus b, x plus 2, right, plus x minus 2 into a plus sub b, a minus sub b, x plus 2 minus x plus 2 is equal to y plus 5 plus y minus 9 and y plus 5, okay, a minus b, minus means minus y plus 9, okay, x get cancelled, this is 2 get cancelled, here become 2x into 2 is equal to, okay, 2y minus 4 into y will get cancelled, this is 14, right? Something is mistaken. Sorry students, the blunder is, okay, I given wrong. Okay, see, the point is on x-axis, therefore the y should be 0 here. Okay, this whole equation becomes wrong. This happens. Okay, at the x-axis y is 0, so right now the answer becomes okay, right? Right now, similarly, x minus 2 whole square plus 0 minus 9 whole square is equal to, again, x minus 2 whole square plus 0 plus 5 whole square. You can take the point x1, x2, whatever, because there is a square is there, so you can do something, okay? You can take x2 minus x1 or minus 2 minus x or 2 minus x. Okay, denote here because you have this square. Okay, this I am writing x minus 2 whole square minus x minus 2 whole square, right? This is, okay, 25 minus 81 becomes right side now. Okay, a square minus b square, a plus b, x minus 2 right? A plus b, x minus 2 plus x minus 2, a minus b, x minus 2 minus x plus 2 is equal to 81 minus 25, right? 81 minus 25, 71, 61, 56, I think so, right? 56, 25 we can add, 27, 6 plus 81, right? 56. This becomes 56, okay? This becomes 2x. 1 is x plus 2, no? This is x plus 2. Right? X plus 2, right? Plus 2 get cancels, and x is getting becomes into 4 is equal to 56. 4 ones are 4 ones are 4 fours are 2 ones are 2 sevens are, x is equal to 7. Therefore, the point x y is equal to point x0 is equal to 7 0. Let's check the answer also. 7.1. Right? 7.14, 7.17, minus 70. Okay, this is the minus side, no? Minus side, minus side, minus side, minus side. Answer is minus 7, 0. Right? Okay. Another one question is solved. Last question, I think so. Find the values of y for which the distance between the points is 10 minutes. Okay, last question, sorry. Find the y for which distance between the points P2 minus 3 and the Q is 10y, D is 10. Okay, the given points and D is 10. Find the value of y. Okay, apply the formula. D is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. See, in exam we don't need to write this formula. For 1 mark question, MCQ questions. For 2 mark question, 3 mark question, just you can apply the formula. I have to consider x2 is 10, x1 is 2, and x2, y2 is y, and y1 is 3. Just put the values. Put the 10 here, 10 they given. So this is x2 means 10 minus 2 whole square plus y2 is y, y1 is minus 3 means plus 3 whole square. This is equal to square root of 88 means 64 plus y plus 3 whole square, right? Y minus 3 means right. Square on both sides. Okay, square on both sides. You will get 100 minus 64 is equal to y square plus 6y plus 9. Expansion, right? This will get 26 minus, okay, 26 is equal to y square plus 6y plus 9. This implies, right, y square plus 6y minus 17 is equal to 0. How? Okay, this is 36. 36 minus 9 is, okay, 36 minus 9 is 6 minus 3, 27 I am getting, na? 36 minus 9 is 27 I am getting, right? Right. So this becomes an quadratic equation. Y square plus 6y minus 27 is equal to 0. Okay. Again use the which one distance, which one? Formula, root formula or middle terms. Okay, 9 to 3, 27. Y I am writing, this is plus 9y minus 3y minus 27 is equal to 0, because 9 into 3 is 27, plus 9 is 6 minus y is common, y plus 9 minus 3 is common, y plus 9 is equal to 0. Therefore y plus 9 or y plus 3 is equal to 0. So value of is minus 9 or y equal to minus 3 plus 3. Therefore y is the point, okay, is equal to minus 9 or 3. What is the answer? 7.1 minus 9 plus 3, right? Okay. Okay, see, this is the distance formula. Is very only one thing you should remember: d is equal to x2 minus x1 y2 minus y1 whole square. That's all. If you remember these things, then okay, that's enough for whole this section, distance formula section. Okay, the very basic equation. So here you can find the units also, find the value of x, find the value of y, and find line equation. Okay, that thing they will ask you question. But one thing is here, these two parameters, the one parameter, two parameter, and third parameter. Distance they will give, one point they will give, again they will ask the other points with giving some axis. Okay, right. This is the introduction. So next class we will discuss about the section formula. There are only two concepts in coordinate geometry. Right? Introduction to trigonometry. Only there are two concepts in this coordinate geometry. A section formula is okay. This is important for exam purpose. In next video, I will come to the section formula. Okay. Here the mini exercise part I skipped here because I am coming with the answers to questions. Next, this is the foundation course as I told earlier. In coming videos, I will again update the things and come to the question and answers. Okay. Let's conclude this one. And thanks for watching the video. Bye.